Okay, good afternoon. We'll see the remaining part of the last unit, that is Unit 5, Economic Analysis of Solar Systems. So today we have left with payback period to be discussed. So coming to the last remaining part of this unit, that is payback period of the solar systems. Okay, so that we'll discuss now. Yes. Yeah. From here now we have left with the last part of this in module 5. Okay, now coming to this payback period. So as the name itself indicates, payback. So whenever you think of, take an example of vehicle. Simple example is a vehicle. Okay. So assume that I have one petrol vehicle now. Later, I am planning for going for the electrical or the solar vehicle. So comparing these two vehicles, now whenever I calculate the cost incurred for a given number of years, say for example, I'm using 5 years the same petrol vehicle, and now I want to compare with the electric vehicle for 5 years, same 5 years, and whether is it going to be benefited comparing to the uh, now as I am using the petrol vehicle, whether it is benefit after 5 years with respect to petrol engine or petrol vehicle or not. And also, this payback period is nothing but whatever the cost I'm going to spend. Okay, whatever the cost I'm going to spend on this petrol vehicle as of now, or on the conventional fuel as of now for the power generation, what cost is uh, incurred. Say for example, as a regular conditions, I consider fuel cost, maintenance, okay, other services or repairs. These all costs, whatever is added, other than the initial cost, what is spent on the vehicle. If I consider that total cost, whatever is spent on the maintenance, repair, or the fuel cost, fuel is a major cost. So if this 5 years cost, whatever is spent on the petrol engine, if the same cost, if it is reduced or if it is below this cost, if I go for the solar system or the solar car or the electric car, then I can tell that the payback period is within 5 years. Or if exactly at 5 years, if I get any benefit, okay, more savings of these fuel or the repair charges on the petrol engines, what I earlier spending, if I get some other benefits also, and because of these benefits from the solar car or the electric car, if I get some benefit compared to the regular fuel vehicles, if at 5 years, if the spending on the petrol engine for 5 years, if it is equal to the same cost, whatever I'm getting the benefit also, then that time I'm going to call it as payback period. So at 5 years, I'm going to get all the payback, all the money spent on the any electric vehicle or the other vehicle, which is received, and whatever the spent on the petrol vehicle is also received at the same exact time. So similarly, here also we are going to check the payback period of the solar system compared to any conventional fuel system. Okay, you can say the time needed. Okay, that the payback period is nothing but the time needed for the cumulative savings on the fuel or electricity. So similarly, if you consider a home, I am going to use the electricity which is available from any thermal power plant using a coal or any diesel thermal power plant, or the energy is directly used for some applications. So the savings what I'm doing now, if I go for or if I switch over to the electric vehicle or the what you can say the solar systems or the solar vehicle, so that cumulative savings at a given time, okay, in the case of a standalone system or income derived from the power fed to the grid. So we have taken this example in the hybrid system or the grid connected solar PV system. So that benefit, if I consider with respect to earlier conventional system, okay, so time required to make this cumulative savings, okay, of an add-on system equal to the total initial investment. So say for example, I will purchase now one uh, petrol vehicle, okay, and I'm go on spending yearly. Say for example, petrol vehicle, as of now I'll take example of 5 lakhs, and yearly spending, say for example, it is taking 20,000. So for 5 years, whatever the cost incurred here, total cost, and people will tell electric vehicles are more costly or solar vehicles are very costly. But if I say some benefits I'm going to get, because I'm going to compare with always the conventional fuels what people are using. So if I compare with that, initially cost may be high, but repairs may be less, maintenance cost may be less with electrical vehicles or the solar systems, okay, or maintenance of the fuel charges. There is no fuel charge for the other systems. Say for example, solar system, if I take solar car only, if I take, there is no fuel charge. So in a similar case, if I compare, within 5 years, I may also get the benefit also indirectly, whatever the highest cost I'm going to put in the system, but in 5 years I'm going to get the benefit also, or else I'm going to save on the fuel also. So that time, at which time I am going to receive all the benefits, whatever is spent on the system, okay, this total investment after cumulative savings, that time I am going to call it as payback period. Okay, so in case of a standalone system like a vehicle, if I example if I take, or a small home if I consider a standalone system, the savings on account of fuel electricity I can consider it as savings on the fuel, or cumulative savings I can tell it as cumulative savings on the fuel, CF. It may be by fuel or it may be by electricity, whatever. But here I'm going to focus on conventional uh, energy. So depending upon that, I will tell savings. Okay, and I'm going to denote this quantity, okay, the total quantity with inflation. Say for example, if you are running a vehicle with a petrol or diesel fuel, or any power plant is running with a fuel and it is generating electricity. So in that case, fuel is having some inflation charges. So this we discussed in the last classes to find out net present worth factor and other things. So that inflation cost, if I consider for the given number of years and the initial year, what is paid, so that I can write it as summation of the cost, okay, the cost incurred for the conventional system. That is, first year I'm going to consider as one, and plus inflation rate for the given number of years. So given number of years means 1 to payback period. So here payback period they have taken NP, number of years for the payback period, NP they have taken. Similarly, for the number of years, if I consider, the summation will be taken for j minus 1 years into B. So B is the cumulative savings, whatever is done for the, or savings, what is income. Okay, you can consider it as income, or you can say savings done by the solar system. So that total savings I'm going to consider B. If I multiply both the things, I'll call it as C here for reference. Now once you open this all summations from j minus j to j equal to 1 up to j minus 1 years, or up to NP payback period, if I take the summation open and if I consider all the factors, I can write it as B divided by IF into bracket 1 plus inflation rate of the fuel raised to NP minus 1. So here inflation rate and savings what I'm getting, I'm calling it for the fuel, conventional fuel. So this is equal to 1 total cost. And from this, how to find out this payback period, NP. So NP to find out, I can write it as ln of IFC by B plus 1 divided by ln of I plus, sorry, 1 plus IF. So using this equation, one can find out without any discounting on the fuel. Okay, so what is the time taken to get the pay, or get back the payment what is invested in the solar system. So that I can call it as NP. If I consider without discounting, sorry, with the discounting. Now with the discounting, here there are two concepts. What we remember, what we have to understand is, one, the discounting made on the conventional fuel. Say for example, people say, apart from going to the solar system or the other system, electrical system, better I will give the discount on the inflated fuel itself, like petrol or diesel itself. I'll give some discounting. I take this system and run the show, like taking the discount. That is one thing. Or you can understand in other way also. You can say the net present value of the money. If I consider the value of the money now, okay, so there I have to consider this discounting. Or say, for example, you have invested that amount apart from the conventional fuel system. If you invest any amount in the conventional systems, yearly you have to spend money for the maintenance, repair, and the fuel charges. So if you switch over to the solar systems, there is no uh, spending of the money on the fuel or maintaining or the repair as much compared to the conventional fuel. So in such case, we are going to take this discounting because we are getting some benefit from the other systems, solar system. So to take that advantage of this solar system, we are using this discounting value. So like this, in these three types, we can consider this discounting amount, how this discounting factor is given. So either in some formulas they will give 1 plus IF, or they will consider 1 point that discounted factor or inflation factor. Okay, as like in last class we have seen one problem. There they have taken, see here, there they have taken directly 1.06 as inflation. Here they have taken discounting 1.07. The meaning is same in the equation itself. 1 plus 0.06 if you take, I can write it as 1.06 like that. 1 plus inflation rate divided by 1 plus D. So again same summation up to payback period. So that is will be J minus 1, because whenever you take the cash flow diagram, on the cash flow diagram, if you see for the nth year, okay, for the nth year, I am going to take this value n minus 1. Similarly, in this formula, they have taken J minus 1, because first year we are paying as it is, what is the amount is there. From second year, the inflation rate starts. So like that, it will become n minus 1 here. So the formula also they have taken J minus 1. Okay, now from this, considering discounting, okay, the change in the above formula you can see, the payback period can be written as ln of 1 minus C. C is the this equal to other right hand side total amount. C into D minus IF divided by B divided by ln of 1 plus IF divided by 1 plus D. Okay, this formula, ln formula, can be used when the inflation rate is not equal to discounting rate. Okay, if by chance inflation rate is equal to discounting rate, you can go for same formula, or else you can use this formula below one without using lens also. And this D and IF are same. So what I'll get now, this term will be cancelled. So we left with C into 1 plus IF divided by B, and remaining all terms will be get cancelled if the inflation rate and discount rate are same. Or is better, what I feel is you can remember both the formulas with LAN. Okay, in terms of LAN, you remember the formulas, so that if discounting is not given, you can go by above formula. If discount is given, you can go by below formula. Or one more best thing is, the simple way is, remember the formula for the payback period with discounting and LAN, so that whenever discounting is not given, you can take it as 0. Okay, and even if IF is equal to D, you can use this equation, whatever. So this becomes the main formula, that is payback period can be written as ln of 1 minus C into D minus IF divided by B, whole divided by ln of 1 plus IF divided by 1 plus D. So to understand more about this formula, we'll take two examples, okay, and we'll solve the problem. So here one more example is taken, how to understand the payback period. Okay, so say for example, yearly from the solar system we are getting some advantage, because solar system is a one energy system where we can supply the energy to the grid or the customers, and the cost of the fuel and the repair charges or the maintenance charges are very less. So yearly we may get some fixed savings or the advantage or the income. So that income is shown here, 4,000, maybe euros, dollars, or rupees. So that are the returns. So after some years, say for example, first year I'm going to spend entire 8,000 rupees. Okay, entire 8,000 rupees. If you take one example, 4,000 rupees, once it reaches 4,000 rupees after 5 years, I can tell this is a payback period for the 4,000 rupees system, what I have spent earlier. And depending upon the returns, it is achieving after 5 years. Because initially you have to spend, then yearly I'm going to get some advantage. This is the advantage of the solar system. But if you take the same example for a vehicle, okay, for a personal use, I'm not getting any benefits every year. Simply, I have to run. Once you invest, there is no benefit. It is going to again fetch your money. Similarly, if I spend complete 8,000, so yearly if I get some benefits other than 4,000, so after 10 years, if you see, this time I can call it as payback period when it reaches the invested amount by cumulative savings. Okay, I think some of the students have joined now. How many are there? One, two, three. Okay, once around 30 students joins, we'll discuss about scheme, and later at 3:15 you can take the quiz. Okay, we will complete until that. We will complete two problems. Yes, coming to this first problem on the payback period. Solar PV street light system. Am I audible to you? Hello?
Yes, sir.
Okay. Just inform other students to join the class. Okay. Until
Okay.
that, I'll follow two columns. Yes. So coming to this payback period problem, this example we can just use a solar PV street light system. So all of you assume this or imagine this solar PV street light system, as you can see outside, which is connected to solar PV systems, consisting of two lamps. Okay, three PV modules. How many modules are there? Three PV modules are there. A battery and other associated components. This costs rupees 55,000. So this will be like initial investment. So what is that initial investment? They have already given 55,000. So I'll consider C as initial investment required or cost of the total components for a PV system structure is 55,000 here. The cost of conventional energy saved due to installation is, now see, cost of the conventional energy saved. So because of solar energy system, the advantage is what? We are going to save the conventional energy. Also, we are going to get some benefits. So that cost of conventional energy saved due to installation is rupees 4,000 in the first year. So 4,000, what we are doing? We are saving only in the first year. Okay, and this cost increases. So inflation rate is given here. This cost increases every year. It increases at a rate of 5 years per 5% per year. Means first year as usual 4,000 is the saving. Okay, because of the inflation of the fuel, what is the inflation rate? 5% is going to increase. That is also added to the inflation only, because that is all together is what, because of conventional fuel savings as well as inflation, I'm going to save more in the solar system compared to the petrol or diesel systems or any other coal power system. So coming to this 5% inflation, I have taken IF equal to 5%, 0.05, and cost of the conventional energy saved, that is a cumulative saving. For the first year, if you see, it is 4,000. So depending upon this, inflation rate is going to change after second year, second, third, fourth year. This percentage we need to consider for this 4,000. So you can make a table and you can go on finding, or else directly you can use the formulas. The question is, calculate the payback period with and without discounting. So as I said in the formula, with discounting and without discounting, so better you can use the last but one formula, which is a common formula. Here discounting value is also there, inflation is also there, then initial savings is there, B. So the total investment is there, cumulative savings are there, all together you can substitute. Okay. So we need to calculate payback period. At what period I am going to get the benefit or total payback? What is the invested in the earlier year? So both they are asking with discounting, without discounting. Assume discount rate of 9%. So this discount rate you can assume either indirectly for the solar system itself, Or else you can assume for the fuel system or the conventional fuel what discounting is done. Okay, if discounting is not done for the conventional fuel system or the conventional energy system, then the period will be very fast. If any discount is considered for the conventional fuel system, then what happens? The payback will be taking very long time because discounting or the rates are very less. You can see the solution. So for the first case, I'll take without discounting. Discounting value is not considered. So I'll substitute in the formula, that is ln of IF plus or minus D. So D is not there. I'll take only IF into C. C is the initial cost, 55,000. Inflation rate is 0.05. B is the annual savings. First year saving is B, 4,000 plus 1. Divided by 1 plus IF. IF is 5%, 0.05. Just substitute the formula, you get the payback period in years. So this is without discounting on the fuel. So fuel charges are very high, means payback period will be very fast. If the fuel charges are reduced because of the upcoming electric systems or the solar system, some fuel companies what they will do, they will start giving discounts. In such case, if I consider discounting, so with the discounting formula, if I substitute, that is ln of 1 minus D minus IF divided by B into C, whole divided by ln of I plus F divided by 1 plus D. If I consider this, okay, then payback period will be how much? It is coming around 21 plus 21.4 years. So many times we take without discounting and we'll find the payback period. So this discounting is for the fuel. Next similar problem, same equation they are using. Okay, so here this is the last problem. We'll complete this and we'll come to the same. So here we need to find out undiscounted payback time that covers 63% of an annual load of, read the sentence once again, 63%, this percentage is not a discount or inflation. Okay, so this solar energy system, what it will do? It will cover 63% of an annual load of 185 gigajoules. So 185 gigajoules, out of this total load, 63% of the energy supplied by solar system. Okay, and costs, what is the cost? 15,100 euros. So for our assumption, we take rupees, 15,100 rupees. The first year fuel cost rate is, okay, the first year fuel cost rate is euros or rupees 9 per gigajoules. So for the first year, if you take the fuel cost without inflation, first year as present value, so that costs 9 per gigajoules, maybe rupees, dollars or euros, and inflates at 9% per year. So it is going to inflate for 9%. Every year it is going to increase. What is going to increase? The fuel prices. Is that clear? So now coming to the solution. So initially, as I told, the cumulative savings. So what is the cost it is going to save? It is going to save the cost of 15,100 rupees by the solar energy system. Because solar energy system that covers 63% of the annual load, which costs, see here, what it is saving, the savings, what it is costing is 15,100 rupees. So you can consider here cumulative savings as 15,100 rupees. Okay, and inflates. What is going to inflate? The fuel prices are going to inflate because all these savings are with respect to fuel and solar energy. So total savings will be 15,100 into 0.09 with the inflation. Okay, then whole divided by, here earlier what you have taken? Earlier you have taken ln of these values, but we don't know here what is the total cost. Okay, so for finding that total cost required, total cost or the initial cost required for the solar system, that can be found out by using these values. Now here for 185 gigajoules, okay, out of this 185 gigajoules, what is the percentage of solar energy supply? Only 63%. Remaining percentage is only from the conventional system. So I'll take this 185 gigajoules. Out of this, 63% is from the solar system. So solar system considered is only 63% of 185. I hope you are getting. Okay. So that is multiplied into this 9. 9 is what? The cost of the fuel per year. Sorry, cost of the fuel first year is 9 rupees or 9 euros. Is that clear? You can assume this as fuel price. FL can be assumed as a fuel pricing. So for 185 gigajoules, okay, first year I am going to pay 9 rupees. But out of this money, we are spending only from the solar energy is how much? 0.63 because of the 63%. So that value is considered plus 1 divided by ln of 1 plus IF is the inflation rate. So because here undiscounted rate we have to find out. So D is not involved. So this value is coming around 9.6 years. After 9.6 years, I am going to get the benefits or the income from the or the total profit. You can say profit after payback period. Until payback period, whatever the profit is there, it is used only for paying the loan or overcoming the investment. So until it matches the total investment, we cannot say it is a profit. So after 9.6 years, I can say this solar system is giving me a profit. Next is last case with fuel costs discounted. If the fuel, whatever the fuel you are paying, 9 rupees per gigajoules, which inflates, because solar energy fuel will not inflate and it is also not costing. So anytime if the fuel is given in the solar subject, you can take it for the conventional fuel only. So that is discounted rate. What is the discounted rate for fuel is 7%. If discounting is done for the conventional fuel, then prices of the fuel and the fuel running systems cost will be reduced. So in that case, if you consider the discounting, so same formula with discounting 0.07 they have taken, okay, and ln of 1 plus IF divided by 1 plus D. If you take, I can write it as 1.09 for inflation. Similarly, 1 plus 0.07, I can write it as 1 plus 0.7. So finally, I'll get the payback period. If the conventional fuel is discounted, then payback period will increase for the solar system. So that is around 13.7 years. Okay, so like this we are finding for the given fuel system, conventional system, we are going to compare with inflation, discounting rate, and with the solar system, what is implemented. At what year, after what time, I am going to get the benefits or the income. Okay, so this ends the fifth unit. Yes, now how many are there? Okay, only 12 students, total 12 students are there. Yeah, can you tell me what are your doubts? Or shall I first tell the scheme of valuation and questions asked in the IA test, and later I will show you the scheme and valuation pattern. If I do that, or you want to just clarify the doubts?
Yes, sir. Show scheme.
Okay. So coming to the question paper first. Yeah, can you see the screen?
Yes, sir.
Yes, sir.
I think for this class, maximum attendance is there, around 14 students, because scheme is discussed, marks are involved, correct? So first question was define the Fermi energy. So Fermi energy is the difference between upper and lower band, okay, and that can be measured at any temperature. Sorry, absolute zero temperature. That was the definition, and Fermi level also can define at 50% the probability of electron. Then explain IV characteristics of the solar panel. So better I'll go to the PPT. Whatever I have discussed in the class, I'm going to tell. this curve also, how the intensity of the light or the solar light is going to vary depending upon that voltage and current variation. So these are the two sketches you can draw and explain how the voltage and current variation is going to take place. And this curve at the bottom is similar to above one, just to tell how to find out the maximum power. Only for the maximum power this curve is required. Is that clear? But change with respect to voltage and current, with respect to light intensity, you can take one of the sketch, either this one or